Thank you.
Thank you. So first session after lunch, I hope you are not so sleepy. In case you are sleepy, I am on call this week with some unfortunate planning, so I didn't turn off my phone, so to also get some adrenaline to you, in case there is a pager. Okay, so let's start the talk. So I'm from Zalando, Cagdas, as a software engineer, and today, as the title says, and as a subtitle maybe I can tell you also how to push the limits of the Elasticsearch when sorting. So let's start. I will give you first some numbers about Zalando, and then the challenges that we have in Zalando, and what is data-driven sorting, and the 3 improvements we did for fast iteration, and 1 open source contribution we just recently did, and given the status quo, how we do the sorting in Zalando, and hopefully sometime for QA. Okay, these are some numbers for Zalando. Like I will go through them fast, and there's some big numbers, let's say. And I have 3 interesting numbers lastly. So these 2, we have over 2,000 brands in 17 countries. So Zalando is not only like selling own product, but it's also a kind of marketplace where it has a partner program. So brands also like can put some products in Zalando. And we have over 400,000 product choices in Zalando per country, so pretty big. So disclaimer, this talk is not only about the full text search. I mean, up to now it was most of the time like you typed something and then you get some relevancy, but what we consider by sorting and search is, so this is a Zalando catalog. When the customers goes to Zalando, they don't always use like full text search, like typing something into the search box, but they also use Zalando as a kind of for inspiration or for getting like using some filters and categories to get some ideas what they can wear or what they can buy. And so by search and sorting, we mean all of them, without any full text search, including like just browsing and inspiration. Okay, let's start with the picture. This is a picture from 50s. A woman is dressing mannequin. You might ask, why it's relevant with this talk and conference. So, but if you, so the point is, when I was, so parents are interested with their sons and daughters, what they do at work. So when I was talking with my father, he was asking what I do at work, and he is from textile industry as an accountant. And when I said, so we are sorting Zalando catalog, etc., he immediately recognized, oh, you are a window dresser. So there is a profession for that one. I didn't know. And then I look up, what is it? So window dressers, I mean, this is an excerpt from Wikipedia, arranges display of goods in shop windows or within a shop itself. Such displays are themselves known as window dressing. They may work for design companies contracted to work for clients or for department stores, independent retailers, airport hotel shops. So I think most of us is doing that in e-commerce, right? So now comes now we are digitally transformed correspondents of window dressers, but there are some subtle differences. In brick and mortar shops, we used to have, they had some disadvantages, like they had one space, like one shop window. But in e-commerce websites, you have infinite space. You have catalogs, you have home pages, you have PDPs, etc. But in another kind of disadvantages, they have less products. But in e-commerce, we have much more larger assortments. And with those 2 things, like with infinite space and larger assortments, the problem of paradox of choice come to, right? And okay, how do we solve these paradox of choice in Zalando? We use data, as you might guess. So our team name is data-driven sorting, and we gather data and try to solve the sorting problem by using data-driven. So therefore, our team is called data-driven sorting. Some challenging numbers that we have. As I said, we have over 400,000 products, and those products are updated 4,000 times per second, and we have live in 17 different countries, and this 15 is a quite interesting number for me. So it means we have 15 different stakeholders. So it means from even market managers to like management board, from the pricing team to the warehouses, everyone wants to have a saying in the sorting, because this is the way that how they can steer through the assortment. But not only some numbers, but also some events are quite challenging. Like a think like a heat wave. Sorry. Okay. Think like a heat wave in Europe. So your past data shows that people start buying vintage products on September. But thanks to climate change and their deniers, now it can be 29 Celsius degrees in Berlin on September, right? And due to this reason, how are you going to update your learned model with the climate change? And then another problem is, let's say you're like this promotion thing that we already spoke with the previous talks. You have a promotion for a specific brand, which is Zalando doing, like we had this Ivy Park, and fans of your this brand or this celebrity is coming to Zalando and start buying a lot of products of this brand. Now your catalog might be overwhelmed with those products, which is good. Maybe you are making great GMV, maybe you are quite profitable, but the problem comes with the other brands. Now they might start complaining, why do you only show Ivy Park products in your catalog? So, another one, Black Friday. Probably now it's a thing in Germany for some couple of years. So, what it does, it introduced quite biased data for a couple of weeks. So, customers during Black Friday period they do not reflect the same behavior on other times that when they use Zalando. So how to deal with this biased data? So I can't give you a silver bullet to solve this solution, to solve these challenges, but and satisfy the different stakeholder wishes, like the brands, etc. But however, I can tell you one trick. So what we do is we fail fast and iterate faster. So what does it mean? So how do we do that? Is validating ideas and implementing them quickly. And to achieve that, we had to take some steps for faster iteration and change our architecture and change our approach to the problem. So what we aimed for is the classical life cycle of machine learning to take it production. So first, we design a solution, a machine learning solution, or some heuristic, right, for what most popular means when you do sorting. And then we do a lot of A/B tests with this design. We do the analysis of this A/B test, and we start again from the beginning a new solution or take it to production. So those are the 3 improvements that we achieved for fast iterations. I will talk about them. I hope this can give you some ideas. Steering. So what we do is like steering sorting towards a target. We introduce this as an improvement and not depending to other services for indexing. In fact, it's for data ingestion. And the last one, sorting with functions. Now, let's go into details. First improvement, sort steering. So I am not going to give you like examples with Elasticsearch or Lucene, etc. I hope lots of you are familiar with the SQL. So I will use some SQL tables and SQL queries for example. So let's assume this is our articles, how we store our index SQ1. I hope most of you are familiar with this SQ, SQ2, SQ3. And let's say we are grouping them to some buckets due to business reasons. Because, I mean, let's say some business reasons are they're bucketing them. And then, as discussed earlier, we are assigning them some popularity score. The way that we sort without any full text search query is nothing but like this. Select from article tables and order by bucket descending, popularity descending. So then this comes to, like the sorting becomes like this. So SQ2 is on top now due to business reason, and SQ3 and SQ1 is sorted now due to with their popularity. But this is quite static. We want to be more dynamic there when sorting. Our aim was using different fields depending on the context, right? So let's say our data scientists come with an idea of sorting male Zalando categories in a different way. So if the category gender is man, they say we do not want to use the classical popularity, but we want to use a new definition of popularity which is designed for men. So like this is how it looks like. So let's say if category gender man and a different SQL statement, or the other one is different SQL statement. So, okay, how does this SQL translates into the architecture? Let's look at this. So when people come to Zalando, and when they select the popularity, they go to the Zalando DE, and then they go to our search API. In the search API, it was like pre-sort steering. It was like popularity was translated into some like list of fields directly, and then this query was sent to the Elasticsearch, and then how was this is all about the sorting. And then we introduced sort steering. So to have this desired architecture, we decoupled search API and created these dedicated sort steering servers. So when sort steering when search API now gets a popularity sorting, it goes to the sort steering to ask, okay, what does popularity mean in this case, given this context? And then sort steering translates it to use some different fields. Then the articles are sorted. So in its essence, sort steering is a rule engine. It matches a search context with a rule and picks respective rule for sorting. And the good thing is new rules can be added dynamically, and you can also add new matchers with these rules. Don't worry, I will show you an example of the rule. So let's remind. So category gender man, and we are using popularity male, and for else we are using popularity. So we want to A/B test this, right? And what we do is nothing but introducing a rule. So these rules like this. Example, so I created this rule for MICES, and so it's integrated with our A/B testing framework, let's say Octopus. And how it works is, so if the customer is in the control group variant, use the classical sorting for popularity. But if the customer for the page gender man, if the customer is in the treatment group, use field popularity male to sorting. So by using this approach with the different rules in many countries, in many categories, or in many different contexts, we were able to do a lot of A/B tests. So second improvement was, so we decoupled data ingestion for sorting. What does it mean? So again, SQL, so insert into classical ones. So let's say we have an SQ1, but we only want to change its performance and performance new formula, like popularity and popularity new formula. But in case of like Elasticsearch, etc., the way that we use it, we aggregate the article completely and then sort the whole document into the Elasticsearch. And it was supposed to look like this in the SQL. And now look at the architectural view, how it was done. In this case, this architecture corresponds to this kind of SQL. So that we have an article aggregator in Zalando. Lots of teams are using it. So it aggregates data from different sources like price, stock, sorting, sizing, and partner. As you see, also sorting. So it was pulling data from different services, and then it was sending data to Nakadi, which is an open source solution from Zalando. Or it's an HTTP layer on top of Kafka. It's a queuing mechanism. And then our intake layer, like indexer, was consuming directly this one and then putting the Elasticsearch. It means whenever we want to change something in sorting we had to trigger to article aggregator, and it has to go to the price, stock, sorting, sizing, and partner. So now comes to rescue with the, again, relational database approach, normalization. So now still we keep the other tables irrelevant to the sorting for now, let's say, in a new table. And then just before we send this data into Elasticsearch, we join the data. So how it looks like as architecture diagram. So we still have price, stock, size, partner. Article aggregator still pulls data for those ones. And then we bridge between Nakadi and our internal search, internal Kafka, and put this partial aggregated view from article aggregator into our Kafka. Then we have our sorting fields. Now it's not only like some popularity scores, but also raw fields which we are going to use, I will show you, into a stream. And then we have a solution where we join those streams, like stream joins, like table joins in SQL. We stream join those two streams, and now our indexer is consuming this join stream and putting Elasticsearch. So what it does is, so it simplifies when we want to introduce a new field or when we want to introduce new data. We are completely independent from other services. So, and we can just push the data and wait for stream, like this Kafka stream joiner to consume it, then it will end up in Elasticsearch. So the third improvement we did is sorting with functions. So all fine, all of these changes are fine, but not enough. We wanted to iterate even faster. So without waiting, like indexing new fields, etc., by calculating some new fields. And we want to use functions for sorting. So what it means, before what it means, sorry, Elasticsearch supports it with something called painless script. In Elasticsearch, this is the only Elasticsearch query, hopefully I will show you. Again, we will fall back to the SQL. You tell Elasticsearch sort on script, and you then give it a script like here in this example. Okay. So if we can drive a field, like let's say popularity, the way that we calculate popularity is sales over clicks. And if we can drive a field from existing fields, we do not need to put popularity again into the Elasticsearch, but we can just use some formula like this script to calculate popularity. This eliminates for re-indexing of the new fields. Like, so we define popularity, and when we order by, we just give it a function with some existing fields. So we want to have this. Okay, this approach seems like promising, good now, but it opened us also other, like not only eliminating reindexing, but other opportunities such as personalization. So let's say you have articles and you also store article features, like article features in this case as an example, its price, its stock, and its size, right? And then you can, since since painless scripts also takes external parameters from your request, you can now pass customer features into your painless scripts, and which, in the end, which you can have just a dot product, and then sort them, like just personalize the search results. And in case you don't know customer, you can still fall back to the popularity. Okay, you might ask, okay, Chadwick, good, but where does full text search stand for? Now, with our approach, with the painless scripts, full text search is also quite trivial to experiment. So if you can get somehow relevance score from your full text search query into function that you are using for sorting, then it means your function can also use the relevance score. In this example, if it is a full text search, use relevance score to sorting the entire Zalando catalog, but if it is not a full text search, just use some other fields except relevance score. Okay, to put all of those things into place, how does it look like? Like a sorting with personalization, with relevancy score, and with popularity, right? This is, again, a rule for us. Let's say we are doing A/B test, MICES A/B test group, and we are sorting by this field, which is personalization, like a dot product. Sorry, here. The personalization can be nothing. Just if you want to experiment, just get the article features, just get the customer features from your parameters, get your article features from your documents, and then do a dot product. So where does query relevance come? In fact, this is a bit wrong, so it's not underscore score, it's params underscore score, but bear with me. So then you can just add underscore score, which is relevancy score, which is either BMT25 or any model that you tuned for relevancy. This score is passed into your painless script, and then you can combine full relevancy score as well. And popularity, as is discussed, right? You don't need to introduce a new field each time, but you can say popularity is nothing but sales over clicks. Maybe if you have other solutions, you can, like, I don't know, multiply it with some additional numbers. So you might now, okay, this is how it works. Coming to the open source contributions we did, relies on this rectangle. So this is you might now say you have code in config, right? It's quite irritating. How do you test it? How do you even develop it? How do you put it there? So don't be afraid. these green lines come to rescue. We are able to test this with we give a test bed, and then the tests are applied. But who is applying these tests? Now we implemented a tool. We hopefully make painless script development painless. It was a bit painful before this tool. So it lacks a bit tooling. The painless, up to, I think, Elasticsearch 6, there was no endpoint for execution API for painless scripts. They introduced in one of the latest versions, painless execute API. So there you can send your scripts and then get the output. By using this endpoint, we developed a tool. I hope it will move into the Zalando repository, not my name, soonish. And then you can integrate your painless scripts and your roles into your CI/CD pipelines and ship your painless scripts quite confidently. So this is my colleague's laptop, how it looks like. So we have a, let's say, big band script, and you have some documents with some tests, and whenever you save or you change some files, your scripts goes to the painless execute API and runs and shows the output of it. And instead of, it has a couple of commands. Instead of this execute command, you can also use it as test command, and you will run your tests automatically. But it's not enough. Like, you might say, I mean, it's in master branch, don't get confused. You might say, okay, good, you write, I mean, you are doing the personalization, whole 400 articles, and how are you sure with its performance? Like, if this for loop that I showed had a lot of features, right, your script performance might degrade. So to test this, we also added a new feature called performance to our painless script development tool. So you give it a query, Elasticsearch query, you give it a script, and repeat this n times, and then it gathers from collectors its latency distribution, latencies, and then it reports its latency distribution. And I can tell you, we're supposed to start an A/B test with a couple of personalization features last week, but it delayed a bit. But we only tried personalizing the whole Zalando catalog with just sizing data, and we didn't see any degradation with with the script sorting. It looks quite good. It has some pitfalls, but I can talk about later. And this is how our test cases look like. So, like, you pass params, customer features, let's say 1, 1, 1, 1, 1. Customer is quite irrelevant here. And article features are 2, 2, 2. And then you expect that products will be 10, and plus their popularity, expected result is 10.1. And this is example, like a direct example from our production, where we test or learn to rank popularity scores with some other factors where we call price cluster, and those tests are passed. Now we can update our scripts continuously and deploy continuously. And sum up. So sort steering let us run many A/B tests by just introducing new rules so that we can validate, invalidate our ideas with different sorting solutions. So we decoupled indexing from other services, and this let us put any data into Elasticsearch without depending or stressing other services. And sorting with functions allowed us trying ideas without introducing new fields into Elasticsearch by only using existing fields. One thing, so this is Armani catalog, okay? And this is George Armani. Do you know any connection between them? Do you have an idea after this talk? Armani was also a notable window dresser. So the guy, I mean, I think the point is, as the whole people in the e-commerce search is a kind of window dresser, now we are like little Armanis here, and we are working, but we are working with now data instead of directly with like some personal taste. And yeah, that's it. Thank you.
Thank you, Taras.
Thank you. That was very interesting. I'm just curious about the performance of the sorting with painless. So if you sort at index time, it's quite performant. but there you actually run scripts at runtime, at query time.
Right.
So don't you have like much? I mean, the performance is not much more less performant. Your system is not less performant.
Good question. I was also surprised it didn't. With only by using personalizing with a signal feature, it didn't degrade not at all. I mean, like we have 300 milliseconds SLI for our search, and it was not breached at all. It was just regular. And we also did with more signals. Last week, I was hoping sharing results in the talk, but it delayed. But the load test we did also didn't like introduce that much latency. It does introduce around like 50 milliseconds to 100 milliseconds, but it is still within your SLO. But there are some pitfalls with painless script, but I'm not going into details of it. But just giving you an idea, you do not try to use dynamic typing, but static typing. It at least give you like 10% boost if you use the static typing.
Thank you.